All right, we're going to look here at patterns and kind of look at the number sequences and then determining if it's arithmetic, geometric, or neither. Patterns, we're going to use patterns a lot, and we see that happen in the real world a lot. They help us kind of figure out what's coming next and how to plan for it. So let's just start with this investigation first. So it gives us a design, and it says make the next two figures in the pattern below. So we see figure 1, it was just a hexagon. And then they added 6 squares to it. The third one, they added 6 more squares. So if we keep going at this pattern, so our next two terms are fourth and fifth, we're going to add, we're just going to add 6 squares. So just like they did. Okay, so that would be our next term. These would be orange. Let's see, there we go. Okay, and then so for the next one, we're going to do the same thing, except this time we have the one we added on the previous one, and now the second one for this fifth term. So we're just going to go and keep adding 6 each time to each next figure. Okay. Okay, so we drew the next figures following the pattern, so adding 6 each time. So number 2, how many blocks do you add to each figure to make the next figure in the pattern? Well, that was 6, because you add 1 to each side of the hexagon. Okay, and it says copy and complete the table below. Okay, so now to do this, the second figure, there was the original 1, and now there were 6 more, so that gives us 7. The third one, we added 6 to 7, so that's going to be 13. The fourth one, we added 6 more, so 13 plus 6 is 19, and then so on. So 19 plus 6 is going to be 25. 25 plus 6 is 31. 31 plus 6 is 37, and then 37 plus 6 is 43. So now that we know the sequence, we know what to expect, we can just start adding 6 to get our next terms. Okay, so to describe the pattern, of what we're doing is add 6 blocks to the, here we go, add 6 blocks to the previous term. Okay, so you can see that's the pattern that we're following. Okay, so this is what we call a sequence. So the sequence is the set of numbers that follows a pattern. So here you'd have set 1, 7, 13, 19, 25, and so on. Those are the numbers that are following a pattern, that pattern of adding 5. Okay, and now this one in particular is an arithmetic sequence. So arithmetic sequence is that one that is formed by adding a fixed number to the previous term. So up here we added 6. That was the fixed number that we kept adding to the previous term. So we're going to look at this. We're going to look at some sequences. We're going to come up with an arithmetic rule. Just in that arithmetic rule is just explaining what's happening. Okay. And so right here we're given 12, 7, 2, minus 3. So we want to look and see, especially when dealing with arithmetic, is there a number we can keep adding or subtracting from the previous one to get that next term? So if you take 12 and you minus 5, you get 7. Now let's see, if you minus 5 from 7, you get 2. If you minus 5 from 2, you get negative 3. Okay, so we found our fixed number. Okay, you keep subtracting 5. So now to write the arithmetic rule, we're going to start with the number you start with. So we start at 4. So we didn't start at 4. We start at 12. Okay, start at 12 and subtracted 5 or minus 5. You could write it either way. You could also say you added a negative 5 to the previous term. So either one is going to work. Okay, so start at 12 minus 5 from previous term. Okay, so now we know that you're going to start at 12 minus 5, and you're going to keep minusing 5 from the previous term. So there we have our arithmetic rule. We want to state where we start, and then what are the steps that we're doing to get our next term. Okay, so let's look at this next one. We've got 3, 10, 17, 24, 31. So once again, we want to see what is there a number that we can add to 3 to get our next term. So 3, so if we add 7, we get 10. If we add 7 to 10, we get 17. 7 plus 17 gives us 24, and then 24 plus 7 gives us 31. Okay, so once again, we've found our fixed number, the number that we keep adding or subtracting to get our next term. So once again, to write our arithmetic rule, we use the number we start at. So start at 3, and then actually, just to keep it short, add 7 to previous term. Okay, and there we've written the rule. Start at 3, so what do we start at? And then what are we adding or subtracting to get to our next term? Okay, this next one, now go ahead and try it on your own. So go ahead and pause the video, see if you can figure it out, and then hit resume once you've done, and then see if you get the same thing I just got. All right, so 5 plus 3, 5 plus 4. 5 plus 4 gives us 9. 9 plus 4 gives us 13. 13 plus 4 gives us 17. And then 17 plus 4 gives us 21. All right, we've got our fixed number. We have the number we start at. So start at 5, add 4. And once again, I can go previous term, but start at 5, add 4. Oops, that should be to the previous term, or to previous. And there we have our arithmetic rule. Okay, so this was arithmetic. We added a constant number or subtracted a constant number each time. So now geometric sequence is a sequence formed by multiplying the previous term by a fixed number. Okay, so now we're looking for a number we're multiplying or dividing, but remember, division is the same as multiplying by a fraction. So you can address it either way. But so geometric sequence once again is the sequence formed by multiplying the previous term by a fixed number. So let's look and see how that looks. So we've got 27, 9, 3, and 1. So if we multiply 27 by a third or divide 27 by 3, once again, they are the same thing. You get 9. Same thing with 9. If you divide it by 3 or multiply by 1/3, you get 3. 3 times 1/3 is going to give us 1. Okay. So now if we want to find the next 3 terms, we're just going to take 1 times 1/3, which is going to be 1/3. Now we're going to times 1/3 by 1/3, which is going to be 1/9. Remember, multiplying fractions, you multiply numerators, multiply denominators to get your new fraction. Okay, and then one more, we're going to multiply 1 by 1. It's still going to be 1. 9 times 3 is going to give us 27. Okay, so there we found our next 3 terms. We followed the sequence. We've multiplied by 1/3. Okay, so now to write the geometric rule. So same thing as the arithmetic rule. we're going to focus on the number that we start from. So start at 27. And now you could say divide by 3 or multiply by 1/3. And I just went with divide by 3. A little easier and quicker to write. So divide by 3. It could be divide the previous term by 3 or divide by 3. But this lets us know what we're doing. Okay. Now same thing here. Write a rule for the sequence and find the next two terms. Okay, so once again, let's see, is there something you can times 2 by to get 4 that you continue to do? So 2 times 2 is 4. Okay. And then 4 times 2 is 8. 8 times 2 is 16. And 16 times 32 is, or 16 times 2 is 32. Okay, so if we continue this pattern, our next two terms, 32 times 2 is 64. 64 times 2 is going to be 128. Okay, and what you'll notice with geometric, you're either decreasing or increasing fairly rapidly. Okay, so now to write our rule, once again we focus on what we start at. Start at 2, multiply by 2. Okay, so there we've written our rule. Okay, and some you could say start at 2 and double the previous term. That would also work. For the assignment today, putting it more in this form is going to be what I'm looking for. Okay, and once again, go ahead and pause the video, see if you can solve this next one on your own, then hit resume and see if you get the same thing that I do. Okay, this one's going to be a little tricky because you notice it goes to a negative, positive, negative, positive. So at first it seems like, well, you can't multiply by something, but if you remember when you multiply by a negative, so positive times a negative is a negative, but then a negative times a negative is going to be a positive. And so that's going to give us that switch back from positive and negative. So 1 times a negative 3 gives us 3. Negative 3 times a negative 3 gives us 9. Positive 9 times a negative 3 gives us a negative 27. And then negative 27 times a negative 3 is going to give us a positive 81. Oops. Okay, so now if I'm going to continue on to the next two terms, this will be a negative because a positive times a negative is a negative. You're going to get 3. 8 times 3 is going to be a negative 243. Okay, the next term is now going to be positive because a negative times a negative. 3 times 3 is 9. 3 times 4 is 12. Carry the 1. 3 times 2 is 6. 7. Plus 1. So 729. So there we've got our next two terms. Now to write the number sequence, once again, what do we start at? So start at 1, multiply by negative 3. Okay, and now we have our geometric sequence, the geometric rule. Okay, so here's 3 more examples. We're just going to check. Notice I've added one more option, so there is a neither option, so it doesn't follow the arithmetic or geometric. So no number you add or subtract, or no number that you multiply. So those are the options. And here we're just going to determine if they're arithmetic, geometric, or neither. I'm not going to write the rule. I'm just going to go through and check and see. So first, if we add 3, but if you add 3 here, you get 9, so that's not it. You could double it. So 3 times 2 gives you 6, but 6 times 2 does not give you 10. So let's see what is actually happening. So with 3 you add 3, then you add 4, then you add 5. So the pattern, you keep adding one more than you did previously. So there's no fixed number that you're adding or subtracting, and there's no fixed number that you're multiplying or dividing. So this one would be neither. Okay, let's see, 80, if you minus 40, but if you minus 40 from 40, you would be at 0. So I know if you times by 1/2, you get 40. If you times 40 by 1/2, you'd get 20. Half of 20 is 10, and half of 10 is 5. So this one would be geometric. Okay, because we are multiplying or dividing by a fixed number. Okay, last one. So let's see, 4 plus 3 equals 7. 7 plus 3 equals 10. 10 plus 3 equals 13. 13 plus 3 equals 16. Okay, fixed number. We are adding, so this would be arithmetic. Okay. So that is a sequence, or patterns and sequences, how to determine a geometric or arithmetic rule, and to determine what type of sequence it is.